What's up, guys? Welcome back to another Whiteboard Wednesday. I want to take you through a couple of the basics on sleep so you can get a better understanding of what your body does every night. And then with that information, you can kind of start to put together the pieces on what's happening if you can't sleep, or let's say maybe you have to work night shift or swing shifts. What's actually going on in your body when that occurs? And what resources and tools do you have on hand to help you offset some of those negative effects? So within human physiology, we see that in this picture on the left, there's generally a 24-hour clock that all humans have within their systems. And each day it resets based on light exposure. So don't get caught up in all the details of what's going on at what time of day, but just understand that before electricity was invented, we tended to function off of the cycles of the sun and the moon. And so bodies tend to run best on that schedule. They like to be awake and alert when it's really bright and light outside, and then they generally like to try to shut down via hormonal messages that they send to you that you perceive as sleepiness. So bodies are super resilient and they can adapt to a variety of things. So if you have to cross time zones as a pilot, or if you work as a nurse or a physician and you have to work nights, or even swing shifts where some days are nights and some days are days, um, then it becomes very interesting how the body can adapt to those things, but sometimes you can still run into issues. So with that being said, we know based on some research that it seems that most humans tend to quote unquote run out of gas or kind of hit a wall at about the 16-hour mark. So this is generally where that 8-hour sleep recommendation comes into play. But this is where you're going to start to see changes in things like reaction time, physical performance, short-term memory recall, even things like mood regulation and your ability to maintain emotional reactivity. So basically, your ability to perceive empathy and to react to certain situations with a degree of empathy and a degree of compassion. Within this 24-hour cycle, you're going to see that there's a number of factors that influence it. And so typically these are referred to as what's known as a time giver. In German, that word is Zeitgeber. And so that's what it's referred to in the research as. This is including light, food, temperature, activity or movement, social interaction with friends or family, and then things like melatonin supplementation. And melatonin will help to drive the onset of sleep. And so it can obviously skew this rhythm. If you take it at 12 o'clock noon, that's going to drastically change your circadian rhythm or your sleep cycle than if you took it at 9 o'clock at night. And this graph on the right here, it's just a general breakdown of what you would see if you had a sleep study done. So these EEG markers are the different stages of sleep, and then obviously the REM stages of sleep and the corresponding changes in the body, heart rate, respiration, so on and so forth. Now, the National Sleep Foundation, you'll see for adults and young adults, generally recommends 7 to 9 hours of sleep, but you're going to have some folks on the top and bottom end of that bell curve. So some folks are going to say, well, I can do well on 6, and other folks say, I can barely function unless I get 10. You will find that genetically some people are predisposed to be able to function on 6 hours of sleep, but those individuals are less than 1% of society. So we have a large number of folks in society that are surviving on 5 to 6 hours of sleep, but that doesn't necessarily mean they're thriving. They generally tend to prop themselves up on caffeine and nicotine and other stimulants. And so it's definitely not ideal from a biological perspective. And this is a great overview of kind of what your body does throughout the day. We can see core body temperature tends to drop off right as sleep occurs. And so this is important for actually initiating sleep. And this is why when you take a hot bath or warm shower, this can actually almost transiently spike body temperature. And then as it comes down, it helps to drive that onset of sleep. And the brain actually has to cool off about 2 to 3 degrees in order to help initiate sleep. So this is where the cool bedroom recommendation comes from. If you think about this logically, it happens in nature. The sunset, the temperature goes down, it gets dark and it gets cool, and this should happen naturally. The problem we run into is when we're indoors, we're in these environmentally and temperature controlled areas, And throughout the course of your day, you're probably fluctuating anywhere from 70 to 75 degrees, and it doesn't really deviate much from that unless you work outside. So this can be a problem when it comes to initiating sleep if you don't have that temperature drop. Now, the two hormones that you want to pay attention to with sleep are cortisol and melatonin. There are many others, but these are kind of our two main players. And so as we start to get sleepy, this is about 9 o'clock, we're going to see melatonin starts to rise and then it peaks in the night. And vice versa, cortisol is actually declining over the second half of the day and it's lowest right before we go to bed. So melatonin helps to drive the onset of sleep, but it won't keep you asleep. Cortisol helps to actually drive wakefulness and alertness, and so you're going to see this peak in the morning. So one of the problems is when someone has cortisol higher later in the day. So let's say they work out right before they go to bed, or they get into a stressful argument right before they go to bed. They're working on stuff for their job or for school. This can drive up cortisol, helps you to pay attention, helps you stay alert. But from a sleep perspective, it's not helpful at all. And similarly, when folks take melatonin and they wake up in the middle of the night and they say, well, melatonin doesn't work for me, the important thing to remember is that melatonin is a hormone specifically, it's not a supplement, but it drives the onset of sleep. So basically right here at around 9 o'clock, but it doesn't keep you asleep. There's other hormones and neurotransmitters which do that. So it's very important to remember that if you can't fall asleep, melatonin can be beneficial, but if you can't stay asleep, melatonin is not the solution. So last but not least, long term, what is sleep deprivation actually doing to me? Does it really matter? I know a lot of people that don't sleep very much, they seem to be fine. When you look at the research on this, it's pretty clear. From an acute perspective, you're going to see short-term changes in your health. So you're going to see changes in immune function, you're going to see changes in cortisol output, you'll see drop-offs in physical performance, alterations in how the body can handle stress, lower resiliency, higher susceptibility to acute infections, such as like the flu, the common cold. But chronically, you're going to see this show up as reduced quality of life. And from a general perspective, it's going to be generally correlated with all-cause mortality, meaning all the different things that could potentially reduce, or I should say all the things that can potentially kill you, basically, that can shorten your overall lifespan. And so on the right, you're going to see a breakdown of all these different systems and the associated complications that can happen as a result of sleep deprivation. And so it's not a direct link. It's not like if you don't sleep, you will become overweight via obesity, but it is the type of thing that sleep deprivation does lead to dysregulation in those hunger and appetite hormones, leptin and ghrelin. It also shifts the propensity of what types of foods a person will choose, whether it is overly processed versus a whole food, and whether it's a higher in protein versus a higher in refined carbohydrates. So there's a lot of different factors there. But the important thing to keep in mind is that these sort of long-term complications take a while to show up. You're going to see these acute ones initially. If somebody starts to, sleep 5 hours a night and they're used to sleeping 8 hours a night, you'll see that straight away. But people don't really start to pay attention until these chronic ones show up, and that's when things start to get a little bit more complex. So just generally keep this in mind. If you're finding that you're struggling with sleep, please reach out to us. This is something that we deal with on a daily basis, but there's lots and lots of different things you can do in terms of just lifestyle, but also how you approach your nutrition, and also even additional supplemental considerations outside of the other things that I mentioned before. So if you have any questions, feel free to drop them in the comments below. We'll be more than happy to help you guys out.